All right, welcome to the video for lesson number 8 homework assignment, factoring trinomials. Most of this is a review of the things that you learned way back in Algebra 1. I know we went over and focused mainly on the AC method, but remember for every one of these, we always want to look for GCF first. Sometimes GCF will actually make things slightly easier for us to factor. So let's take a look at the first one. So for the first question, I see 6, 48, and 90. So I'm going to divide 48 and 90 both by 6, and I can see that there is actually a GCF there. So if I divide out 6, I wind up having 6 x squared plus 8x plus 15. That allows us to factor using the normal trinomial method. So the 6 kind of just hangs out outside. And then we're going to say what multiplies to make 15, but adds to make 8. That's plus 3 and plus 5. All right, let's take a look at the next one. So for the next one, there is no GCF, and there is a number in front of x squared that's other than 1. It's 3. So we have to use the AC method. So for the AC method, we're going to multiply these two numbers together. That gives us negative 60. So I'm going to rewrite this as 3x squared minus 20. Now, in class, we were talking about the signs and how we kind of already know the pattern of the signs is going to be negative and plus, so that it will look the same. It'll be a positive, a negative, a positive, and negative. It has to have kind of like a pattern like that. Okay? So now I have to say what factors of negative 60 will add to make positive 4. Well, 60 has a lot of factors, right? But 6 and 10 work the best. So if I take positive 10 and negative 6, that'll multiply to make negative 60, but it'll add to make positive 4. Then we can separate this up into two groups. All right, this is actually something we're going to learn a little bit more about in the next lesson. It's called factor by grouping. And we can factor out the GCF of the first part, leaving us with x minus 2. Positive 10, leaving us with x minus 2. Notice these two parentheses are the same. So there's a GCF here, which is x minus 2, leaving us with 3x plus 10. All right, let's take a look at another one. So for the next one, again, we're looking for GCFs. There isn't any. So I'm going to multiply these two terms together, and that gives me 100. So then I'm going to rewrite this as 4t squared. I know they're all going to be plus because there's all pluses here. And then what multiplies to make 100 but adds to make 25? Well, that would be 20 and 5. So I have 20t and 5t. It really doesn't matter where you put them. If you put them in the other spots, you'll still be factorable. Doesn't really matter, right? So now if I factor out the GCF of the first two terms, I have 4t. So I become t plus 5 plus 5, which leaves me with t plus 5. Notice t plus 5 is common, so I'll put that first. And then the 4t plus 5 is the common factors. All right, so in the next one, there actually is a GCF, x, leaving me with 5x squared minus 41x plus 8. But again, we can't factor that as is using the normal method, so we have to use this new AC method. So we get 40. So because I have 40 now, I know that I have to find things that multiply to make 40, but are going to add to make negative 41. So the x is kind of going to stay. I'm going to have my 5x squared. I know both of these in the middle have to add up to a negative number, so they're both negative numbers, and the last number is positive 8. So I'm going to use negative 40 and negative 1. Doesn't really matter where I put them. So I'll put 40x here and 1x here. First two terms have a common factor of 5x, which is going to leave me with x minus 8. The last two have a common factor of 1, so I could either divide out positive 1 or negative 1. Well, if I divide out positive 1, my signs are going to be incorrect when compared to what I factored out over here. So I'm going to factor out negative 1. So then my final factorization is going to be x parentheses x minus 8, 5x minus 1. Right, we can't forget about this x that we factored out earlier. Right, that's got to come down into my final answer. All right, let's keep going here. 2 more. So next one also has a GCF. GCF in this case is going to be 4. So if I divide out 4, that gives me 2m squared plus 5m minus 3. Again, AC method here. So 2 times negative 3, well, that's negative 6. So it multiplies to make negative 6, but adds to make positive 5. Well, that's going to become 2m squared. I know I'm going to have a plus 6m minus 1m minus 3. Can't forget about the 4. GCF of the first 2 terms is 2m, leaving me with m plus 3. Last 2 is negative 1, leaving me with, again, m plus 3. The nice part about this factoring method is you know if you're right or not, because if these 2 don't match, there's something wrong. So now your final answer is going to be 4 m plus 3 times 2m minus 1. All right, the last one, this is a kind of a throwback question. This is something you did in Algebra 1. Notice, instead of having x squared or m squared, this first term is x to the 4th power. All right, so let's see what changes here about this. So again, no GCF, so we can just go straight into the AC method. So I have negative 36. So I have 9x to the 4th power. All right, what multiplies to make negative 36 but adds to make positive 35? Well, that's going to be positive 36x squared and minus 1x squared. Notice I'm using x squared there in the middle instead of x because it's x to the 4th x squared. So my exponents are larger, so I have to use larger exponents in my problem. Now from here, we'll look at GCFs. GCF of the first 2 terms is 9x squared, leaving us with x squared plus 4. GCF of the last 2 terms is minus 1, leaving us with x squared plus 4. GCF here is x squared plus 4, not factorable, and 9x squared minus 1, factorable, right? I can still factor this using difference of 2 squares. So one of the things that we really need to look at in this class is we can factor things multiple steps, right? So since this is a factor completely question, we have to look for that. So I have x squared plus 4, and an 9x squared minus 1, well, that factors to 3x plus 1, 3x minus 1. All right, so every time that we're factoring, once we get to the end, or quote-unquote what we think is the end, we want to ask ourselves, can I still factor anything? Difference of 2 squares comes up a lot in this case because it's going to be binomials. So it's not going to be GCF because we're dealing with that already throughout the problem. So it's probably going to be difference of 2 squares. I might even get crazy and give you one that's difference or sum of 2 cubes. So look for all of that. Hopefully this video was helping you. Please make sure you're watching the videos to check your homework before you come into class. This way we can keep going throughout this course. Best of luck.